Have you ever just, been completely baffled by the choices teenagers make? Or maybe you look back at your own teenage years and think, what was I thinking? Driving those intense emotions, the daring stuff, sometimes just weird decisions. Most of us feel like we kind of get adolescence, right? But today, we're going deep, peeling back the layers to get at the fascinating biological why. Welcome to the deep dive. We're digging into a really key chapter from Robert Sapolsky's amazing book, Behave, The Biology of Humans at Our Best and Worst. We're exploring the adolescent brain, and honestly, the science is way more intricate, maybe even surprising than you'd expect. So our mission today is to give you that shortcut to being well-informed. We'll unpack the science, why adolescence is so unique, what's actually changing in the brain, and how that shapes, well, everything. Risk-taking, emotions, even empathy.
Yeah, and the absolute core idea here, the thing that explains so much is this delay. The frontal cortex, the brain CEO, it doesn't fully mature, it doesn't really come online until the mid-20s. And it's not just like an unfinished brain. It's a brain going through a very specific, very crucial developmental phase. It shapes who we become.
That really changes things, doesn't it? Because the old thinking was, your brain's mostly wired up in early childhood. I mean, by age 2, it's already like 85% of its adult size.
Right.
But Sapolsky shows it's this much slower journey, especially for that one bit, the frontal cortex. So what's actually happening there?
Exactly. The key fact is that the frontal cortex is the last region to finish maturing. Synapses, insulation, metabolism, all of it. Think of it like building a city. The basic roads, the power grid, they go up pretty fast. But the central command tower, the bit handling judgment, impulse control, planning, that takes way longer. Not finished till your mid-20s.
Wow. And Sapolsky calls out two screamingly important implications from this. First, that adolescence shapes the adult frontal cortex more than any other period.
Absolutely.
And second, you just can't understand anything about adolescence without knowing about this delay.
It sets up this really interesting situation. Your emotional system, the limbic system driving those strong feelings, that's like going full blast. Your basic body systems too. But the pilot, the frontal cortex, still learning the controls. So you got this powerful engine, but the person steering is still, well, developing.
And that neural jumble, as you call it, leads to some pretty wild extremes in behavior, right? Sapolsky's list is incredible.
It really is.
Kill, be killed, leave home forever, invent an art form. It runs the whole gamut from, noble acts to dangerous ones. Help overthrow a dictator, ethnically cleanse a village,
Devote themselves to the needy, become addicted, transform physics.
have hideous fashion taste, break their neck recreationally, mug an old lady. It really paints a picture of maximum risk-taking, novelty-seeking, and this huge pull towards peers.
Which brings up that question, is adolescence biologically real? Or just something culture made up? I mean, sure, Western culture might have stretched it out puberties earlier, having kids is later, but the neurobiology is clear. It is a distinct phase. It's not just a half-baked adult brain or, as Sapolsky jokes, a child's brain left unrefrigerated. And most traditional cultures see it as distinct too, even if they define it differently.
Okay, so the frontal cortex is under construction. How does that work? What are the nuts and bolts? And here's where it gets counterintuitive, right? The gray matter neurons and connections, you'd think it increases.
You would, yeah. But it actually decreases during adolescence.
Increases?
Yeah, it's this idea called neural Darwinism. See, the fetal brain makes way more neurons than needed. Then comes this competitive process, pruning. The winning neurons make good connections, migrate right. The unfit ones, they get eliminated, program cell death. It makes the whole circuit more efficient, more optimized. Less is more, basically.
Okay. So for the adolescent frontal cortex, it starts out thicker, more synapses than in adults.
Exactly. Then over the next decade or so, that thickness goes down as the less useful connections get pruned away, streamlining the system.
Making it more efficient.
Precisely.
Yeah.
And it's not even uniform. The older parts mature first. The really high-level thinking part, the dorsolateral prefrontal cortex, that doesn't even start pruning until late adolescence. And there was this landmark study showing the longer the gray matter develops before pruning kicks in, the higher the adult IQ. So maturation isn't just about more brain, it's about a better, more efficient brain.
And you can actually see that inefficiency, right? Like adolescents use more frontal cortex energy for tasks adults find easier.
Yeah, that irony detection example is perfect. For adults, reading those subtle social cues might involve other areas, maybe the fusiform face region, almost automatic. For teens, still a full-on frontal cortex job.
Okay, so gray matter decreases. What about white matter, the connections themselves?
Well, that increases. The axons, the wires, they get more myelination, more insulation throughout adolescence. Think of like insulating electrical wires. Better insulation means faster, more coordinated signals. Different parts of the frontal cortex start talking to each other better, working as a unit. It's all about the network, the circuits, not just isolated spots.
And other brain parts try to chip in too. You mentioned the ventral striatum helping with emotions.
Right. It's usually part of the reward system, but in teens, it kind of helps out with emotional regulation, like it's working overtime, covering for this still developing frontal cortex.
And then there are hormones. You can't talk adolescence without hormones.
Oh, definitely not. That huge surge of gonadal hormones at puberty, estrogen, progesterone, testosterone, they directly change the brain, including the frontal cortex. They affect myelination speed, neurotransmitter receptors. It's why maturation milestones often track better with time since puberty started than just chronological age.
Right. Makes sense.
So yeah, picture it. Frontal cortex efficiency is still being toned, diluted with extra synapses. Communication's a bit sluggish. Different parts aren't perfectly coordinated. The reward system is pinch hitting for emotion control, and it's all swimming in this hormonal soup. Is it any wonder they act, well, adolescent?
Exactly. Okay, so how do these brain changes show up in actual thinking and feeling? Cognitively, you see steady improvements, right? Working memory gets better.
Yep, holding and manipulating info. And also mentalization tasks, basically.
Yes.
Figuring out what someone else is thinking or feeling, like detecting irony, understanding their perspective.
But emotional regulation, that's different. Teens feel things more intensely.
They do. They show bigger brain responses to strong emotional faces. In adults, a part of the frontal cortex, the ventromedial prefrontal cortex, or VMPFC, helps calm that response down, lets us get used to it. But in teens, that VMPFC response is weaker. So the amygdala, the emotion center, just keeps firing strongly. The feeling doesn't fade as quickly.
Which makes strategies like reappraisal really key. That's reframing things, right? Bad grade isn't I'm dumb, it's that test was hard or I didn't study enough. Situational.
Exactly. And teens get better at this, but the brain machinery changes. Early on, that ventral striatum, the reward center, actually tries to do some of the reappraisal work. If it's more active, the teen regulates emotion better. But as they mature, the prefrontal cortex takes over that job properly, leading to steadier emotions usually.
Okay, let's talk risk. That California cavern story is chilling skeletons at the bottom of a huge drop, always adolescence.
Yeah, it sets the scene. And the science backs it up. During risky decisions, teens activate that prefrontal cortex less. Poorer risk assessment. Sarah Jane Blakemore's work showed that bias. Teens update their odds for good news, just like adults. But bad news, they kind of ignore it. That drunk driving statistic, that won't happen to me. 1 in a gazillion chance.
Which helps explain why things like pathological gambling rates are so much higher in teens.
2 to 4 times higher, yeah.
And it's not just more risk. It's different kinds of risk-seeking. The bungee jumping versus cheating on the diet example.
Right. And related to that is novelty seeking, just craving new experiences. It peaks in mid-adolescence. And it's not just humans. Adolescent rodents explore new foods more. Young chimps and baboons actively seek out new groups. It's this deep drive for the new.
And dopamine's involved here, isn't it? The reward system?
Hugely involved. Dopamine signaling actually increases in adolescence, both in the main pleasure center, the nucleus accumbens, and in the frontal cortex itself.
So rewards feel bigger.
Kind of. There was this great study with brain scanners and money rewards. Kids, fairly steady response. Adults, response scaled with reward size. Adolescents, whoa. Bigger than expected rewards felt amazing. Smaller than expected rewards felt actively bad, aversive. Sapolsky calls it like a gyrating top, nearly skittering out of control. That immature frontal cortex just can't easily regulate that supercharged dopamine system.
But here's the paradox. Teens can reason like adults on paper, right? They often score similarly on logic tests.
They can.
Yet, as Sapolsky says, logic and reasoning are often jettisoned. And Lauren Steinberg found the key factor. It happens when around peers.
Peers, yes. That famous driving game study really showed it. Adults drove the same, whether peers were watching or not. Teens, their risk-taking tripled with peers in the room.
Tripled? Wow, why do peers have such enormous power then?
Well, teens are just intensely social and complexly social. Remember that study? Average 400-plus Facebook friends. Their social world is huge and deeply tied to emotions, to affect. There's this almost desperate, frantic need to belong.
Which can unfortunately lead to things like deviance training, right? Peer pressure towards negative stuff.
Exactly. Increased violence, substance abuse, risky sex. As Sapolsky jokes, you don't see many teen gangs pressuring kids into flossing regularly.
Yeah.
And you see it in subtler ways, too, drinking in dorms, the way eating disorders or even depression can spread through friend groups, through co-ruminating.
And the brain scans show something amazing here for teens. The brain pattern for what do I think about myself looks almost identical to what does everyone else think about me?
It's incredible, isn't it?
Yeah.
Self-concept is essentially outsourced to the peer group. Who am I? Whatever they think I am.
That cyberball study nails the rejection sensitivity too, where they feel excluded from the game.
Right. Adults feel bad, sure. You see pain, anger areas light up. But then their rationalizing part, the VLPFC, kicks in later. It's just a stupid game. Teenagers, that VLPFC barely activates. The emotional hit is bigger, lasts longer, they feel way worse. Rejection just cuts deeper, which fuels that need to fit in even more.
And there's even a link to imitation. Teens susceptible to peer influence show more premotor activation, like they're ready to copy emotions.
Yeah, especially for emotional faces. It's like their brains are primed to mirror the group's feelings.
Okay, shifting slightly. Perspective taking gets better, but still not fully adult-like. They can see how someone feels, but maybe struggle with a detached third-person view.
Pretty much. And moral judgments get more sophisticated, too, moving beyond simple fairness to considering merit. But still less complex than adults understanding individual situations better than, say, systemic issues. They also get much better at telling intentional harm from accidental harm, seeing intentional as far worse.
And that shows up in the brain. Less pain activation for accidents, but more frontal cortex work for intentional harm.
Exactly. The DLPFC and VMPFC get more involved when processing intentional harm. It becomes a frontal task to really grasp the awfulness of someone being hurt on purpose.
But then there's this other side, what you called one of the greatest things about adolescence, that intense, almost overwhelming empathy.
Yes, that frenzied, agitated, incandescent ability to feel someone else's pain, not just for them, but feeling as them. It's incredibly powerful.
And it makes sense, right? With all those high emotions, the openness to novelty, which Sapolsky links to an open heart, maybe that feeling of omnipotence too. The world needs fixing, and I can do it.
Like that Quaker idea, all God has is thee. With their energy and that feeling, yeah, it seems possible to make the world whole.
But there's a catch to that intensity. Feeling too much empathy can actually backfire.
It can. This is really interesting. High empathic arousal, high anxiety can actually make you focus inwards on your own distress. And that makes you less likely to help. The key to effective action seems to be gaining a bit of detachment, being able to ride rather than be submerged by the wave of empathy.
So ironically, the adolescents' intense empathy, their hearts on their sleeves, might actually disrupt their ability to act effectively sometimes.
It can, yeah. It's a paradox.
And then the flip side, that adult frontal cortex allows for detached good, but maybe also makes it easier to just detach completely. Not my problem.
That's the risk, certainly. Now, we also have to touch on the darker side. Late adolescence, early adulthood, it's the peak time for violence, all kinds. It drops off dramatically after that.
It's a 30th birthday crime-fighting tool.
Exactly. And just to be clear, it's not testosterone causing it. Levels peak earlier than violence does. The biology behind the violence is similar to the positive stuff. Emotional intensity, peer approval craving, novelty seeking, that developing frontal cortex. The path just diverges.
And all this science has had real-world legal consequences.
Huge ones. Because the science shows the average teen just doesn't have adult-level self-regulation or judgment. That led to two massive Supreme Court rulings. Roe v. Simmons in 2005 banned the death penalty for minors, and Miller v. Alabama in 2012 banned mandatory life without parole for juveniles.
And Justice Kennedy specifically cited the science in the Roper decision, didn't he? Talking about their lack of maturity, underdeveloped sense of responsibility, leading to impetuous and ill-considered actions.
Precisely. It acknowledged the biological reality.
So what a journey. From baffling teen choices right down to the brain's wiring. That delayed frontal cortex maturation really is the key, impacting pruning, hormones, emotions, reward, the power of peers, everything.
It really ties it all together. And Sapolsky leaves us with this fascinating final thought. Why did evolution do this? Why the delay? It's probably not because the frontal cortex is just harder to build. The thinking is it's delayed so the brain gets it right. Being last means it's the part least constrained by genes and most shaped by experience, by life. Which makes sense for us, right? A supremely complex social species. We need that flexibility, that shaping by experience to navigate all the complex choices life throws at us.
Wow, that really makes you think. How does knowing all this change how you see teenagers, or maybe how you remember being one? What does it mean for how we support kids through this incredibly important, sometimes chaotic, but also amazing time? We hope this deep dive gave you that shortcut to being well informed, spark some aha moments. Thanks so much for joining us.